think we're good to go. Okay, so this is just a real quick talking through my solution to 8D question 4. I'm asked first of all to find the cubic term for this expansion. So what I need to do is expand the second bracket to the power of 4. So I use the binomial expansion, but because I only want cubic terms, remember I'm going to multiply 2 plus x by my expansion. So my x cubed terms are going to come from 2 times my x cubed term and x times my x squared term. So in my binomial expansion, I need the x squared and x cubed term from this bracket. Well, the x cubed term will come from the second part being raised to the 3, so the minus ax to the 3, and that means of course 4c3 and 3 to the power of 1, because remember the power was always add to the 4. And the x squared term, well, my second term will be raised to the power of 2, so minus ax squared, so it'll be 4c2 and the power of 3 will be squared. So here we go, I've expanded this. 4c3 is 4 times by 3 minus ax cubed. Remember, this means not minus a minus x cubed, it means minus ax times by minus ax times by minus ax. So a negative times a negative times a negative will be negative, and then it's a cubed x cubed. So that term gives me minus 12a cubed x cubed. The squared term, 4c2 times 3 squared, there it is, 4c2 is 6, 3 squared is 9, and clearly minus ax squared is a squared x squared. And then I'm going to multiply my cubic term by x. No, I'm not, that's not true. I'm going to multiply my cubic term by 2, there it is. So that's minus 24a cubed x cubed. And I'm going to multiply my squared term by x. So it's not a full expansion, I'm just doing what I need to do just to get the x cubed term. So my x squared terms times x, there it is. So my x cubed term of this whole expansion looks like this, x cubed times by 54a squared minus 24a cubed. That's not the whole expansion, it's just the x cubed term. I missed out all the steps that I didn't need to do. Okay, I'm told that this coefficient is equal to 30, so I've divided by 3, written in the order that I want descending powers of a, multiplied by minus 1 because I don't like that negative coefficient on the front, but that's just me. Now, depending on the question, and I'd suggest for this exercise, you could probably just stick this into cubic mode on your calculator. We do need to be able to solve these, of course, and the only way we know how to solve cubics, when I haven't got an a term that I could factorise, because there's no a in that third term, the only way I know how to do this is to use the factor theorem. So what I did was, I went into table mode, I got a value of a which sent it to 0, which meant a minus 1 was a factor, and then I did it by inspection, but of course you could use a grid if you want to. I did my division and I got my quadratic factor. So either a minus 1 equals 0, or 4a squared minus 5a minus 5 equals 0. That's the only way we can solve these cubics. I hope you can see where my quadratic solutions came from there. In fact, actually, I'll tell you what I did. I put that into quadratic mode. 4a squared minus 5a minus 5 equals 0. I put that into quadratic mode and we calculated, but I could just as easily have put that into the quadratic formula to end up with that, couldn't I? So I hope that helps. Yeah, the difficult bit was, okay, silly mistake with the signs, but the difficult bit was remembering how to solve this cubic. And remember, the only way we know is finding a factor using the factor theorem, find the quadratic factor, and then sticking that into the quadratic formula. But like I say, for the purposes of this question, for this exercise, I would suggest probably could have used cubic mode on my calculator. Doesn't say for the question, does it? Okay, I hope that helps.